The hashtag EENA 2018, please tweet to your heart's content. 30% more retweets if you put a picture in it. I'm Brian Maguire, I'm a journalist from Brussels. I deal a lot with digital content, artificial intelligence, cybersecurity, and the kind of subjects we're about to speak about here this morning. Artificial intelligence to most people means losing their jobs to the robots. Probably not. But here today we're going to speak about artificial intelligence and saving lives and the context of the emergency services. And we have some great speakers here today, as you'll have seen from the program. We're running behind time. We're going to make up for that. We're going to change the structure of what we're going to do this morning, but more free flow. And we're going to get some Q&A from you as best we can in the same time frame too. So we appreciate your attention for this. Our keynote speaker this morning is Andreas Cleve, Chief Executive Officer, Corti in Denmark. Andreas, all yours.
Thank you. Hi, guys. So will the future demand more or less from emergency departments? To us, I think it seems pretty clear that it's going to demand a lot more. It's going to demand faster response times, higher accuracy, better triaging, more resources on site, which is quite a lot to demand when we're facing one of the hardest challenges already, and we're seeing increased call volume. We're having a harder time finding the right talent we need at the right time, and new legislation and demand and even technology is being pushed on us all the time. So ultimately, how do we face it and what do we do in the future as these demands will meet us? I come from a company called Corti, where we gathered a team from some organizations you might know to try to help emergency departments beat the odds of fast and accurate dispatching. We started in Copenhagen, and what you see here is a lot of dots. And every dot is 100 emergency calls made to EMS Copenhagen in 1 year. And a lot of these cases, of course, are highly critical. And one of these cases that are highly critical, where mistakes are intolerable, is a cardiac arrest or out-of-hospital cardiac arrest. And as you'll see, if you can, the red dots here is 100 calls per dot, hidden away in the vast volumes of the calls made during a year. So although the emergency dispatchers in Copenhagen, they're very well educated, well trained, and has great tools, only about 2/3 of these calls are detected during the call in the right time, which of course is really great work, but ultimately it leaves every red dot of 100 calls not being detected and giving the treatment they need in time. This is of course critical, not only because cardiac arrest, like many other incidents, is bound by a time issue, so about 10% decline in survival rate per minute we don't detect it and offer the right assistance. But it's hard, since dispatchers, of course, are facing, which all of you, of course, know, inconsistent information. So the bystander or patient might not be giving the right information at the right time, which can throw off a protocol easily and increase errors and, of course, dispatch time. So we asked, how could we help emergency departments beat those odds and do what we do even faster using machine learning? And we did that with Emergency Service Copenhagen and the EMS in King County, Seattle, where we actually built a system that builds on a premise that we can help dispatchers by having them stand on the shoulders of all the knowledge prior dispatchers have already learned. So this system listens in on a call as it progresses, follows the dispatchers, but don't interrupt, but tries to help them by looking at all the historical calls and see if it can come up with cues or patterns that could be helpful. And this is quite amazing, since at the moment when we took it back to Copenhagen and for 2 years tested it on actual calls, we could go back to a scenario that looks sort of like this. So instead of having about 2/3 detected, we could bring it to a quite astonishing 92% detection rate. So 92% instead of 2/3 of the calls were now detected, and even better, on the first run in Copenhagen, we could do it a half a minute faster when humans and computers work together. This is only cardiac arrest. It's 1% of the call. It's 1 in 80 at the most. So ultimately, if this technology is so good, is AI just here to replace us all? We're going to sit on an island and do painting? No, of course not, since ultimately AI in my mind and in our mind is based on a premise that's faulty, which is that we're building intelligence that tries to imitate us, to take our place and act autonomously. That's not supposed to do it like that. That's interesting. So all of a sudden, this was going to show you a graph where we've been told for a long time that AI is going to be here. And that started back in 1996 when Kasparov lost a very, very famous game of chess to a computer called Deep Blue. So he won the first game, he lost the second and asked for a rematch, but the company IBM wouldn't let him. So ultimately, he found a way to get revenge. But the problem was, before I tell you about the revenge, is that ever since 1996, we've been told in a moment artificial intelligence will be here. It's going to replace us, it's going to do our work better. But ultimately, I think what majority of us, I'll share this online so you can actually see my stuff, but ultimately what I think all of you and myself has experienced is that we actually sit in a situation where we're still waiting. We're not having great experiences conversing with Siri. She's not giving us great aha moments all of a sudden. We're thinking, oh, that's revelating. We're having more of the what the moments when we interact with these technologies, and that's okay if we're surfing around the internet or playing around with the technology. But in our case, we're facing problems where errors can't be tolerated. And we've already seen that this kind of technology creates errors we can't tolerate. But the premise is still the same. If we build technology to only act on its own, we're facing problems as soon as we end up in a situation where we can't afford the errors. So we asked, what about letting intention, purpose, questioning still be a human endeavor? And so treat technology like this as something that assists us. And that's what we propose. Instead of talking about artificial intelligence, the replacement paradigm, let's build technology that makes us better, that supplements us, that tries to emphasize our strengths and help us with our weaknesses. That was a great picture again. Really bad presentation. But ultimately, we've been doing it for a long time. Ever since we invented the first pair of glasses or a hearing aid, we've been building stuff that makes us more. And that was also how Kasparov got back at Deep Blue. Since next year, he invited everybody back for a tournament. We're going to play chess again. And this time, you can bring your AI, you can be an expert, you can do what you want. And guess who won? Like Kasparov, the AI expert that had built his repertoire even better, or was it Deep Blue or another? And no, it was a mediocre chess player with a mediocre set of AIs working together, supplementing each other. And we think that's immensely powerful, and that's the thing we've been trying ever since with EMS Seattle and EMS Copenhagen to build, is something that builds on our strengths. So instead of replacing us, what about supporting us? What about assisting us when we need it and leaving the floor to human and the endeavor of finding purpose, meaning, and asking questions? We think this is going to elevate not only chess playing, but also emergency dispatching. As what this technology can do is it can be present with the dispatcher who usually sits there alone as they're triaging every phone call, and now we can give them all the knowledge of all the calls ever made before and give them cues they need to perform even better. So instead of sitting alone with a headset, we now have the accumulated knowledge of all the prior emergency calls in a single case. And we find that immensely powerful. And today we are here to offer something we find quite unique, which is a partnership. So we made a partnership with EENA about giving this technology to 5 emergency departments or emergency organizations for 1 year for free, fully deployed in your reality, on your language, on your problems. We'll come to your site and work with you with a full set of data scientists to prove that we can also give your dispatchers the tools they deserve. Thanks.
Thanks, Ben. Listen. Peter Overton, where are you? Come join us. Thank you, Andreas. Please take a seat. You guys get yourself some water. Yossi, you take over there. That's it. You take over the side there. Thank you. Take a microphone with you. Okay. That one there. Thank you, Andreas. That was great. We're going to go a little more free flow now. I'm going to ask each of our panelists to introduce themselves, 60 seconds, who they are, where they're from, why they're interested in AI. Andreas, we already know you. Let me introduce our panelists first. William J. Josko, Associate Partner at Public Safety and Policing Segment of the Global Government Center of Competency, Global Business Services, IBM. Kirk Arthur, Managing Director of Worldwide Public Safety and Justice at Microsoft. Yossi Matias, Vice President of Engineering at Google, on the end here. And Peter Overton, Partner Leader for Justice and Public Safety at Deloitte Consulting Australia. Welcome to all of you. Bill, you going to kick off?
Absolutely. Well, good morning, everyone. And as you probably saw my last name, Josko, I'm told it's really Josko in this area. So I'm hopeful I have some relatives out here. We'll know soon when I get the DNA test back from Ancestry.com. But in any event, I'm absolutely honored to be here today. I've had the honor and privilege of serving public safety now 30 of 35 years. And actually, my roots start from the dispatch environment. Some of my very first engagements were with CAD and records and mobile, sitting with call takers, sitting with dispatchers. These are in the days of green screen. And now, of course, we see technology and all of the incredible promise of AI, Internet of Things, next-gen first responders. So it's an amazing time. And for my duties at IBM, I support the globe in our public safety, emergency management, and justice and corrections endeavors. So we work with our local teams in the various geos and really try to look at how do we infuse AI and other advanced technologies in an embracive, cooperative manner, not a rip and replace, because you have your point solutions that you use on a daily basis. But how can we amplify those with our technologies? So that's my main mission, and I'm certainly honored to have done it for 30 years.
Thank you. Kirk, let me bring his microphones over. Kick off.
Does this mic work? Yeah, so Kirk Arthur with Microsoft, and I look after global public safety and justice. Really almost a very similar role to Bill with IBM. And same, how can technology facilitate and help the first responders? How can it help the court processes and the court correction space? And how is that all intertwined? And it's really exciting times, I think, where technology stands today. And the ability to bring agencies around the world to have collaboration, AI, machine learning capabilities. To start, probably, Andreas, I thought that was a great presentation because it is a force multiplier for your staff. It's not a replacement for your staff, and I think that's a key differentiator. I came to Microsoft about 3.5 years ago. I came from industry. I was a special agent with the United States Secret Service for about 15.5 years before joining Microsoft. Complex white-collar fraud investigations. I was at headquarters in Washington, D.C. I spent 4.5 years on our presidential detail. My last 4 years, I led cyber crimes teams on the West Coast of the United States. So cyber is a fundamental thing we'll get into in my session after this one today, but cyber does need to be the foundational discussion when you think about AI and what technology you're using, just so you enhance your posture secure and how you move forward. And before Secret Service, I was a police officer, so I'm an operational guy more than a technologist.
And you promised to tell us all the secrets of the US government before we finish here today as well, yes?
Over beer, yes.
Okay, excellent, thank you. Peter.
My name's Peter Overton. I'm a management consultant by trade, so my role is effectively to, as Ed said, get people to pay me hundreds of thousands of euro to implement the technology that these gentlemen build. I sort of got interested in this after the EENA conference last year, where I ended up with a contract with what's the PSAP for Victoria in Australia. It's a single organisation that covers the whole state, so it covers about 6.3 million people. It handles about a bit over 7,000 calls a day, so it's quite a big entity. And they had a challenge in our population was growing by about 200,000 a year, and the government wasn't willing to stomp up any more money. So I suppose we pitched some of the AI-type technologies as part of a new future operating model, and to be honest, it failed miserably. And I suppose what we learned from that exercise there is we were pitching it as a technology, and it wasn't resonating. It was, people found it scary, they found it worrying, they thought they were going to be replaced. So over the next 12 months, working with other public service organisations in the Australian military, we've changed the story. And what we've found that works is actually talking about AI as an additional worker. So if I wrote the report I did for Victoria today, I would have a new section in it that said workforce, and a subsection in that would say recruiting your first AI assistant. And what we've learned along the journey is probably the key thing at the moment is changing the lens. Remove it from a technology conversation. Start having the conversations with your HR department. Start having the conversations with your operations director, and essentially talk to them about creating an AI worker or an AI assistant.
Thank you. Yossi.
Hi. I'm working on engineering at Google. I lead teams working on search technologies, the kind of search that hopefully you're all using every day. Also teams on developing AI technologies, machine learning, language understanding, health-related stuff. But also leading a global team working on crisis response. And sometimes people are asking me, so why is Google doing technology for crisis response? The answer is pretty straightforward, I think. We saw previously people talking about the need for information, both by people who are affected as well as those who are helping them. We have set up to make such information available for people when they need it most, which is part of our mission, essentially. If you think about search in general, we're looking for information when we need it, and it's quite clearly that during crisis and other such situations, getting the right information to the right people is crucial. So first, I encourage you, by the way, to attend a session tomorrow. Sims is going to present some technologies we've developed and show through search, which in the past year we had many dozens, over 100 of incidents. Hundreds of millions of people actually were looking for such information. And AI, of course, is that's a big emerging technology. It was mentioned earlier about how people were waiting for that. I think that we're only kind of getting started on AI, but already it does huge strides on what it can be doing, what it should be doing. And we have huge opportunity to use technology and AI to actually help out in various fields in life. We're already seeing that also in health and other ways, but the ability to analyze images, to understand languages, to analyze signals, to collect information, to prioritize, to do things in a way that helps us in various situations, and notably in crisis situation, is a huge opportunity. So I think it's a very exciting domain to be in, helping out people.
Excellent, thank you, Yossi. Bill, you got a pilot in the States with Watson. Explain a bit about that.
Absolutely. So many of you have probably heard of APCO International, and they're based in the United States. APCO is the Association of Public Safety Communication Officials. And excuse me, knowing the importance of APCO and all that it does for the PSAPs, from technology research to best practices and accreditation and certifications, when we started to engage with them, I knew the importance of really trying to help them, and specifically, they had the project in mind of updating their call triage software. And this was what they call their criteria-based guide card system. So we worked with APCO, and they wanted Watson as part of this. They wanted an AI element, a 21st century capability. So we worked very closely with APCO's people, and we had something called design thinking, where we brought 4 different agencies in from all over the US, and everyone converged. We had a 2-day session. It really helps to focus the thoughts and where their pain points are and what we can help solve for. So we're about to roll out live this version of the software. It's a state-of-the-art solution with a great user interface where data propagates between police, fire, and EMS automatically. And then the next phase will actually be some of the things that Andreas is working on, and totally agree with the premise of augmentation versus artificial intelligence. And so as we apply Watson microservices, it will be in the call environment, next best action, tone analysis, personality insights, sentiment analysis, audio analytics. And one particular thing that we're very excited about is in quality assurance, only about 3 to 5% of the calls on a monthly basis are QA'd. With this new capability where we'll be taking the audio from the recorder, doing speech-to-text conversion, and then marrying that up to actually their criteria for quality assurance. And we'll be taking the snippet of information. Did the caller verify the address? Yes, it did. And take that part of the audio and append it right under the QA. So in theory, we will now do 100% QA of the calls, and now this leads for more, I'd say, in-depth analysis of our SOPs and procedures correct? Does this dispatcher or call taker need extra training? Are our procedures off? All of those elements that we'll be able to now really showcase in this 100% QA.
Excellent. Thank you. Kirk, feeding the data in to begin with is the critical part. What's missing from the picture at the moment? What data do you think fits with this profile for emergency services that's not there right now?
Well, the data exists. If you think about your operational environment, think about years, decades, and especially in the PSAP space, where you probably have 40, 50 years of legacy systems that currently they do 1 or 2 workloads. They're not integrated. They don't talk to each other. there's this wealth of data in your RMS and your CAD solutions, your criminal databases, jail booking databases. Really, you want to augment and stitch these systems together so whether it's an ambulance service responding, a firefighter, or a police officer, that their situational awareness is at the peak. And it should be a system where it's pushing information. They're not having to crawl that information as they respond to a call for service. And I think that's the fundamental differences, and AI is going to enable that, is you're having that dialogue. And Bill, you touched on a great thing is, I think historically there's been friction between vendor companies and first responding companies. And really with technology where it's at now, is having these proof of concepts, we call them hackathons, where you sit down, let the companies learn from the customer your pain points, what problem you're trying to solve, and then trying to nest it in there. And the technology exists today to do that. And you're starting to see agencies around the world doing these little proofs of concepts with, in Canada, with Ottawa Police Service in San Diego, having automated bots that officers are interrogating as they respond to services verbally so they can keep their eyes up on the road. They don't have to look at the screen and try and manipulate information. And that system's pushing them real-time information, but it's filtering that white noise that can confuse any response posture. So there's just an unlimited capability right now, but foundationally is getting these systems integrated first, and then start harvesting that information and really do some fantastic things.
Excellent. And how do you recruit your first AI assistant for PSAP?
Well, the PSAMs we haven't cracked yet in terms of building them. Our focus we actually decided to actually not start with PSAMs. The whole concept of an AI assistant, we thought we would start actually with the Australian Public Service, because a lot of what they do is not mission critical. And so then we moved on to onto the Australian Defence Force, mainly because they are more experimental by nature, and secondly, they have a lot more money to spend. So what we found, though, following on from the previous comments, is that you can find a different type of AI assistant or AI technology to cover off lots and lots of business processes. So what you actually have to do is outline that business process, and the first decision you can make is this best done by a person, or is it best done by one of these AI technologies? And the AI technologies, we fall into basically three different categories. And once again, we use a persona. We look at them like a person. And we call them either automated assistants, cognitive assistants, or AI advisors. So the first ones, the automated assistants, really mimic human actions. They're really quite simple programs. They're quite often used to move data around, quite often used to fill gaps in existing IT systems. The next one, a more cognitive assistance, is where they mimic human judgment. They're essentially rules-based, and they're sort of trainable. They will provide an answer every time, consistently every time, based on the rules they have. And the last one is what we call an AI advisor. And the AI advisor is probably more the high end. It mimics human decisions, it employs human-like thought processes, and it's self-learning. So it will provide you different answers as its data set builds up. So the first step is to decide whether you need a human to do it, or whether one of these AI assistants can do it, and then pick an appropriate AI. They're quite various. We've used ones that are associated with that analyse video. We've used ones that analyse sound. We've used ones that just transfer and transpose data in one business process. So you end up creating what we call a suburb of AIs in which to produce a particular outcome. So we've been through that journey. We think we now have a series of steps and methods to actually people to start viewing this, not so much as a technology, but as a new kind of worker. And so the emergency management sector is where we're heading next.
Thank you, Peter. Yeah, go ahead.
Yeah.
I just had one comment about the PSAP. Structurally, how they're designed. I mean, oftentimes they sit isolated from a police department or fire department or ambulance service. I do think as PSAPs need to modernize, that even just being foundationally in the same building as those responding services, oftentimes I guess real-time crime centers is how it's referred to, but as a dispatcher, if you're working a job, rather than just be a conduit and a pass-through, if you work in that job in parallel with an officer and you're be able to give eyes on to responding units, I think that's a real big logistical opportunity in the PSAP space, and again, to enhance that situational awareness going forward. So,
okay. Yossi, singularity is coming. What is it, first of all, and when?
Yeah, there are many conversations about it and a variety of opinions, obviously, and many science fiction movies. It's some great movies, actually. So anyway, I think really that obviously we look around. I mean, we can't really, as people are saying, AI is here, but we can't even fix AV yet, right? I haven't been in my life in a presentation that you don't need to deal with this stuff. So we're really very far away from these premises. I would say, however, that focusing on the benefits of AI, I think, is really hugely important. And there are so many different ways. So back to your question, obviously there's the question of, oh, is it going to be kind of a runaway, et cetera, et cetera. I think there are obviously some areas where AI is very strong, obviously identifying patterns, helping out. And therefore, when we can incorporate it in a way that is working well with human in those particular tasks, I think we're going to see huge impact. I think we're very far from anything which resembles a situation where it's kind of on its own or in any shape or form. If I look at the premises of that, so first, one area that excites me really a lot is I think about AI as not necessarily artificial intelligence, but more so as ambient intelligence. So the situation that actually we have this intelligence, something embedded and just helping us. So there were some examples about how we don't think about some of the things that we're using, glasses or information enhancements these days, obviously. And there are many other ways that we're using it on a daily basis on our cars and elevators, etc. Some technologies that in the early days were kind of novel and unique, and now we just don't think about it. Similarly, just think about what it means for people, for incident commanders in this world, or for medical staff in the health industry, to just have the right information just in the right time, analyzed for them, where things are routed. There were questions about drones earlier. What do you do if you don't have enough communication? Well, with AI, you can actually analyze what's important. Just take the right information, bring it to the right place. One example of, now obviously the premise is also to do the analysis of data in a profound way. When talking about crisis, one thing when we looked around and looked into what kind of crises are there, it turns out that floods are killing thousands of people every year, over 6,000 people per year. And some of those, many of those could actually be saved if we have the right information at the right time. So we actually are looking into the question, can we use AI technologies, various technologies of information, and to try and have a better forecasting of floods, having this information back to people who are affected so they can take action, or to the responders who can help them out, is crucial. In fact, we've seen that already. We got some examples where in some floods in the US, we got some notes from people saying, hey, by having this information, we could evacuate in time. And the question is, can we do a better job in that? And we are actually looking at that and working with various organizations worldwide on that. So this is one example of a situation where using AI, we could certainly save lives. There was a mention here earlier about language and understanding people. So again, this premise that think about a situation that you have many people calling and many people talking, and if you could really understand what's needed and solve communication gaps. So for example, sometimes it's as simple as just transferring the language. If we had some crisis here and we could not speak local language, that would be an issue. Translation technology can actually bridge that gap. Now, over time, this is just going to be available to us, and in many cases, it's already available to us in various shapes and forms. So these are some of the examples that are where we're using AI in a pretty profound way. I would mention that the progress is really significant. Kasparov was mentioned earlier as a milestone, but I think perhaps one should also mention the AlphaGo example for the last couple of years, where we've seen a program not only winning a world champion, but also another version of the program where it's learning just from experience. So we can accelerate the notion of AI development by actually let it learn from its examples. But we're going to do that in very specific tasks, and by combining them with the people, we are actually going to get a very high impact of AI, certainly in many areas and certainly in crisis response.
Thank you, Yossi. This is what I wanted to bring on to Andreas as well. The quality of the data and the volume of the data, both of these elements matter. Are you confident that you're getting the data you need to do the job that you want to do? What's missing?
Is it working? So what's missing? I'm not necessarily sure that anything is missing. I think it's more up to us, represented here in the panel, to make sure we make the distance between those who are to buy artificial intelligence and understand it smaller instead of larger. And as I see it, we see a lot of providers who are creating a subset of services around AI which really aren't. And using a lot of language like I am, that actually increases distance, makes it harder buying, makes it harder to understand what you actually need to do to start implementing AI today. And I think looking back at technology, we've seen so many cases where technology becomes not understandable, and we create experts, and we create distance. And usually that's not where the cool things are created. So I think it's up to us to make sure that distance becomes a lot smaller. And I think it's about us taking the risk, coming to you guys, and making it work on premise, on your case, and taking the risk of that instead of always creating these.
What do you find as the barriers? What are the limitations? Why do people hesitate?
I think first off, there's a big discrepancy between, I think you all agree, what especially maybe the media are portraying as AI and what we're able to deliver. And I think a lot of us also see a risk in going there and trying to live up to a phantom of what AI can do, since the dialogue takes a long time to bridge if we aren't on terms with what we're able to deliver.
Okay.
Yeah, can I comment on that?
Yes, all the hands were up. Excellent. Bill, first.
Yeah, so what's interesting is there's so much information out there, but what does it really mean to me from an insight perspective? So we hear terms like big data. It's out there. We're creating terabytes and terabytes of data every single day, more than the past 5,000 years. So the key really is boiling down that data in contextual relevance, in this case, to emergency services, filtering out that noise as we talk about, and really having the vendor communities all cooperate with each other as well. You know, as an example, IBM and Microsoft actually are fast partners from systems integration perspective, et cetera. But as we look at Next Gen 911 as a perfect example, the data and information coming in, the call takers will be deluged. Video, audio, streaming video, pictures, citizens as first communicators on scene, social media. How do we boil that all down in contextual relevance and still have the speed of getting that call out? So that's really where I think the challenge and the opportunity is for AI.
I just want a second, Kirk. This week I did a counterintelligence briefing with some European agents. And one of the things we talked about was the problematic element of dealing with social media and
Yes.
first responders. And the first responder generally in many crises is the citizen with a phone. Olimuros, who you know is a pop star perhaps, he tweeted live from what he thought was a shooting incident in London just before Christmas last year and caused a stampede. And the emergency services were not able to filter that for more than an hour, and the BBC was not able to report on that accurately for more than 2 hours because of the confusion. Kirk, how do you deal with that?
Well, that's a huge challenge when you think about OSINT, and then you think about human intelligence, even signal intelligence. You do need to be able to harvest that information. Back to Andreas' earlier point, though, there's always a disappointment in modern technology. Like if you think about your interview rooms for the policing customers in the audience here, if you have poor quality mics and you're recording on a cassette tape or something, the output, garbage in, garbage out, right? The output's not going to be that great. Or if you don't have high definition CCTV cameras for facial recognition or redaction, it's going to be limited. You do need to make some investments in those environments to be able to do that. But I also I'd be curious to see a show of hands. How many here are open to using cloud technology to do this? And I think that's the foundational barrier no one likes change. Certainly in public safety, cops hate it for sure. But you have to start wading into that space. Really challenge the vendor community. Let us tell you our cybersecurity posture. Let us tell you about how we do compliance. Let's have that super rich, deep dialogue. I spent 4 years, my last 4 years with the U.S. federal government responding to counties and cities that thought their posture was strong, but they had data breaches. They lost track of appliances. They didn't patch accordingly. Cloud makes real-time patching in mere seconds versus days.
There's a budget element as well. You've got about 18,000 police forces in the States, something like that? Yeah?
18,000.
Right.
And how all those forces don't have the resources that maybe a city or an urban environment will have. So
I don't think so. I think you have to think about, I mean, you've made those capital expenditures, and cloud technology lets you leverage that investment till their end of life, and then start looking at modern platform capabilities in that OpEx model versus a CapEx. And that's really the foundational basis of it. Right. Then that opens you up. We can talk AI till we're blue in the face, but if you're not open to cloud environment, it's not going to, you can do a hybrid model for limited capability.
Yossi, Peter, go ahead, and Yossi.
Yeah, a couple comments. First, about the power of using the fact that every person now has technology, a supercomputer essentially in their pocket. So as an example, a lot of the information we showed on maps during crisis, we found out that the best information sometimes actually come from people on the ground. In fact, we showed on maps shelter information that was driven by information given from people reporting, and it was far more accurate than information that actually we got from authorities. Because things are changing very rapidly, and it's practically impossible to track all of that in a centralized way, but actually by having people reporting on that through Waze and other means, we could actually place it. I would also want to note that we talked a lot about technology, but I think one of the biggest trends that we see today, or the biggest shifts in technology we've seen, is really the fact that we can all leverage on these technologies through cloud and APIs, the openness of technology. The fact that every organization, every startup can actually take an API through a cloud for the various capabilities of AI, I think is hugely powerful. And one reason actually why I'm here is also to learn about other technologies and other players, because really one important question is how can we bring various players who are working on various aspects of, for example, crisis, and see that we can actually integrate them in the right way through the same platforms, sharing information, sharing technologies, having access to that. This is one of the big trends, the fact that every person, every engineer out there in the world can take and implement a solution which is based on some of the most deepest AI technologies out there.
I want to take Peter's questions, then we're going to talk quickly about privacy and data, and then we're going to take a couple of questions, and then we're going to get some coffee. Peter.
Yeah, I think the three big factors we've experienced in terms of resistance to change, the first one is the whole use of cloud computing. The amount of computational power you can apply when you bring the cloud to bear is enormous. But getting the various agencies to actually agree to do that is a hell of a task. One of my colleague companies here actually provided us a certain amount of computing power free to actually trial this with a number of the emergency management organisations in Victoria. I think we have spent 3 months working through the various data privacy, data legislation, privacy acts, and we're nowhere near starting. I think that the second barrier is a little bit of what I know as technology debt. A lot of these agencies have technology that is 30 years old. There is 30 years of wonderful data in there that you just can't get to because it was written in some obscure language that was available 30 years ago. So unlocking the power of that data is important. And the third thing is the senior stakeholders, and particularly people who come from an operational background. Quite rightly, most senior people in these organisations apply the risk profile that they use on operations, which is, that I'm putting my people in harm's way, I've got to protect them, I've got to look after them, to everything they do. So getting them across the line requires effectively for you to really demonstrate that you understand their operational situation and to effectively immerse them in the technology. So where you can do it over about a day, if you like, where you get them to explain the various technologies in human terms, not in machine terms, to actually present them case studies and then get them to go through an exercise where they could say, if I had 10 additional workers who were of this capability, how would I use them? Okay. So if I had 10 new process workers, how would I use them? If I had 10 new cognitive assistants who could learn things and apply rules, how would I use them? If I had 10 new AI assistants that I could give to my senior management to help them with their decision making, how would they use them? And they actually go through a pretty good exercise of actually positioning where these different types of technologies could solve the problem. So the three barriers at the moment is getting over the concept of using cloud technologies. I think that's a must. Unlocking what is actually a wealth of data in legacy systems. And the third thing is getting your senior operational stakeholders comfortable with the concept.
Thank you. Let me go to Kirk just for a second. Kirk, there's this startup in America called Facebook. I don't know if you've heard of it. And this guy, Mark, who's really good at looking after people's data, and people really trust him with all their data at the moment. Maybe you've been following that closely. How do you see, with GDPR coming up, the Facebook scandals, the lack of trust, how do you see AI being able to draw down the data across jurisdictions? And Microsoft has had an amicus brief with the Supreme Court recently as well, dealing exactly with this, because we may talk about American data or European data, but it's not actually that. It's a server in Ireland or a server in Sweden or a server in Germany. And the access for emergency services to be able to profile based on those data streams is not as simple as it looks from the outside.
No, I mean, it's extremely complicated, and I can say from a Microsoft perspective, we invest $1 billion a year as a company in security and compliance and that posture. It's very complicated, that Ireland case you referenced. We took that to the U.S. Supreme Court. They just dismissed it because the Cloud Act was passed by U.S. Congress. And you will think, when you think about the Mutual Legal Assistance Treaty process, that is an antiquated process to gain information overseas. Having led cybercrime investigations, it's extremely slow, and it took me 10 months to get information from a server overseas. My case is done. I got nowhere to go. And that's why the underground economy, cyber criminals have gone rampant. They're being unchecked right now. So we do need to be better about that in the public safety and public sector space for sure. All I can say is when you think about cloud technology, talk about compliance. For us, we believe, and I think we are the most compliant cloud in the world, because in the US, we meet the FBI CJIS requirement, the federal government's FedRAMP, DISA 5 for workloads. In Australia, we just launched the Canberra Data Center, but we already met the IRAP standards. In Europe, wherever that is, we're investing in that, and we continue to. And our approach has been to have an umbrella approach to compliance. So whatever your sensitive workloads are there, you meet the requirements that you need to. And we also understand you're not going to put everything in the cloud. It's a hybrid scenario for sure. You're going to have key things you're going to keep on premises. We get it. And that's very important to understand and work through that. But don't limit yourself because of compliance and just say, oh, it's not compliance, we're not going to do it, and not pursue that. Because even for us, you pick where your data goes. You own your encryption keys. We don't see your data. We don't want to see your data. And I think pushing your vendors, whoever you choose, to have that discussion, that dialogue, and really understanding at the 400 or 500 level what that's all about. And we will gladly have that conversation.
Quick comment on GDPR as well. So incredibly complex situation, as we know, and this expectation of privacy. When I had this conversation very recently, let's say a UK citizen comes over to the United States. In New York City, there's all types of cameras that are recording this person. Is that a piece of data that that citizen can say, I want purged? And is there even an association that knows this is Bill Josko walking in New York City? So it's this marrying of the data to the identity, and then being at the request of that citizen, that individual, to say, I want these records purged. And quite frankly, I think the only way we're going to be able to solve some of that is, and a big part of that, is through artificial intelligence. There's incredible amounts of moving parts. There's data all over the place. Like to say, we leave our digital DNA everywhere we go. So, and then from an emergency services perspective, that citizen that needed help, and did they access that EMR somehow electronically? And then what's the procedure for deleting that out of that PSAP's records? So incredible amounts of moving parts and data, and I think AI will be the way to go. And in a nutshell, AI is a journey. Just everyone should really understand that. You just don't plug in and turn AI on. It's very a step-by-step process in what it can do out of the box, what you train it to do with your 30-year practitioner institutional knowledge in what is called machine learning and training the corpus of data. So, and that's key in making this effective in your department. And the last quick point is, as you look at artificial intelligence, don't think you need to go it alone. I would look to your organization like EENA as an example, or in the States, APCO and NENA. These are incredible organizations that can really take the collective thoughts and needs and pain points and really consolidate those down and then do projects that the masses then can accept and actually share the cost in as well.
Thank you. Any quick points to this, Yossi?
Sure. So first, of course, making sure that keeping people's trust and trusted information, of course, is utmost important and something that we should all take very seriously, and we do. With AI, actually, there are some additional important social questions that comes to mind, and we need to pay a lot of attention to. I would say thinking responsibly about how to develop AI. One that is probably the most imminent is about how to make sure that AI systems are fair. They are not unfortunately, we have in our societal behavior a lot of bias, and AI systems quite often, because they're training on real practice, they tend to learn the same bias and sometimes amplify it. So we need to be conscious about it, and we need to make sure as we develop AI systems that they are actually doing a better job than we do as people. And I think there's also an opportunity here. But this is certainly something that requires a lot of good attention. And I think I look at it from an optimistic point of view. There's a way actually to improve how we manage things around. So I think all these considerations are hugely important, and certainly we should all pay a lot of attention to how to make sure that systems are safe, secure, preserving people's privacy in a very profound way. Also, by the way, in crisis situation, I think there was a question earlier about we collect this data. It's hugely important, but we also need to make sure that it's treated in the right way, because these data includes a lot of personal information as well.
Okay. We've pulled back a bit of time, but we're into your coffee time. So do you want 2 questions or do you want coffee? Yeah, right, okay. Let's take 2 questions and we'll finish up. Okay, one here. Got a microphone there? Yeah, great. This short question, tell us who you are, please.
Yeah, John Tevenon from ESTA, Victoria, Australia. So in regard to AI, there's the question of unsupervised algorithms. So the AI makes a decision and we don't necessarily understand how it makes that decision, which is a kind of a very big change of paradigm, because all we do today is to explain how we make decisions to make the better next time. How have you solved, like in the test case you presented, how have
Sorry,
you
can you hold just the final part of the question? Hold it
Sorry.
close. Yeah.
How have you solved that discussion on a supervised algorithm in the trial done in Copenhagen in terms of understanding how does the AI does better and can explain the decision made? Okay,
so how does AI improve the decision-making process, basically?
Yeah,
okay.
And how do you know about that?
Thank you. One other question? Sorry if I can't see you. No? Okay. How does AI really improve the decision-making process? Peter spoke earlier about human judgment. Humans don't have great judgment a lot of the time. So how do we come up with effectively a better product, a better response at the end?
Yeah, I think at least a couple of the scenarios we're observing is where AI helps in the decision-making process is what I would call macro situational awareness, where there's so many factors going on at once that humans can't sort of cope with it. And the example I think of, we're talking to what's called emergency management Victoria, is a concept in Australia, or a thing we have in Australia called thunderstorm asthma. And that's where a lightning storm actually basically obliterates a whole bunch of pollen, and it has an enormous outbreak of people turning up in hospitals. Now, people don't recognise that sort of event while it's happening. They recognised it afterwards by taking all of that data and crunching it. So the aspiration in terms of better equipping, shall we say, the Emergency Management Commissioner, is to be able to take your computer aid dispatch data with your hospital data, with your data from your environment sensors, and with your weather data, and be able to say, dear Mr. Commissioner, this is what is likely to be going on. And so it's about effectively extending that human judgment rather than replacing it.
Okay. Kirk,
if I could
then address that.
Yeah, so New York City Police Department, Microsoft, we've been partnered with them for about a decade now. They have, I think it's about 6,800 CCTV cameras now. Most are privately owned, but they're using our back-end technology to find like an unattended bag on a street corner and not waiting for a human to monitor and say, hey, there's an unattended bag. The system's saying, here's the bag. It calls up the right camera. You can rewind that to see who dropped it off. Maybe you could leverage facial recognition to see last known direction of travel. It's something that the human's going to miss, but the system's not. And it's just streamlining, again, that force multiplication, augmenting the first responder, just to maybe try and prevent or minimize the impact of an event.
Is this to be allied with SOPs in the sense that the machine will prioritize the information you need first?
Absolutely. I mean, that's the first call-up. And then it starts answering questions based on, the input was from all the dispatchers that sit in the real-time crime center. And to your point, teaching those models to think similar to those experienced folks. And over time, you'll have a little bit of a handoff, and the system picks it up.
Yossi, then last word to Andreas.
Sure. I would say I would classify it into two types of assisting. One is addressing situations that actually the AI can do a better job just by analyzing more data. So I mentioned earlier, by looking, for example, at images and trying to apply various complicated simulations of hydrological models, we hope that we could get a better prediction or forecasting of floods than people could actually do, just because it requires a lot of analysis of deep data. The other type is taking the kind of stuff that people could do extremely well, in fact, better than probably any computational stuff, such as hearing conversations or analyzing data or situational awareness, but we just are too busy to actually apply this judgment. Just think about this morning. Everybody who could actually pay attention would know that it would take a lot of time to get everybody in, and eventually, of course, it was the right call to ask people to just come in. But we're too busy to actually look into all these situations and make those decisions. By having AI systems helping us analyze the situation and giving us this advice earlier, we could actually improve so many situations in urgent care situation, crisis situation, and many other places.
Okay, Andreas, last word.
As I understand your question, you were asking, how do you document and understand and govern how the decision is actually made?
Yeah.
And I think that's a hugely important question, since we even built a linear regression model on top of our models to try to explain our models, since it's so deep that we can't say for sure. And I think then the real question becomes, how do you govern us? Since you should. You need to, in my opinion, get our skin in the game. And I think one of the most beautiful pictures we have of it is, how come we still trust doctors? They've been making mistakes, of course, as they've been testing new approaches for decades, because they have an oath that if you're sick and you go to your doctor, you need to at least not get worse. And if you're well and you go to your doctors, you can definitely not get worse and you should get better. That's the kind of oath you should ask us to make, that when we go to you guys, you cannot get worse off. You cannot get more risk. So if we can't deliver to you on premise, then we should get to deliver to you on premise instead of only pushing you guys to go to the cloud, although I'm a big fan of the cloud. But ultimately, I think that kind of oath is what you really need to govern us, since you don't want us to go on compromise with the technology or the solution. You want us to compromise on our gains to make sure you get what you want. And that's the kind of oath we need.
As with so many other things, start with values. Let's thank our panel in just a moment, but before you go for coffee, and I appreciate your time. This is we started so late this morning. The mentioned Microsoft's coordinated response will be taking place as well during the break in the Innovation Theatre as well. Our panelists this morning, thank you, Bill Josko from IBM, Kirk Arthur from Microsoft, Andreas Cleve from Corti, Yossi Matias from Google, and Peter Overton from Deloitte in Australia. Thank you so much. Round of applause, please.